Okay, this is going to be a supplementary video on finding the inverse of a function. At this point, we should have already discussed what inverse is, just in case you don't remember, and I'm going to talk about this real quick. You don't have to write it down. For inverse, we always switch x and y. Okay, as far as ordered pairs go, or a table, graphically we reflect over the function y equals x, which does the same thing as this, which it switches x and y. Okay. And algebraically, we solve. We switch the x and y, solve for y as we learned in Algebra 1, and then at the end, go ahead and change our final answer to f of inverse. Recall that the notation for inverse is f to the negative 1 of x. Okay, that negative 1 represents inverse. Okay, so I'm going to go ahead and jump straight into some examples. And hopefully we can get at least 2 or 3 done. Let's say we have the function y equals 3x plus 2 over 7. Let's just make it something linear. Okay. Well, the first step in this is to switch the x and the y. So from here, I'm going to change this into an x and say x equals, and change that to a y. So 3y plus 2 over 7. Okay. From here, we begin our algebra of solving for y, which is what we used to do in Algebra 1. We solved for y all the time. So from here, I'm going to solve for y. So when I do that, I need to get this by itself. So many of you still do this, which is perfectly fine. I'm going to go ahead and get rid of the 7 first, because that's the farthest term from the y. So because we're dividing, I'm going to multiply both sides by 7, which gives me 7x is equal to 3y plus 2, because this and this will give me a 1. 7 over 7 is just 1, so we're left with 3y plus 2. My next step will be to get rid of this 2, so we subtract 2 from both sides. And now this is where some people might get a little bit confused. This is going to go to 0, so I can cross it out. This, however, these are different terms. So instead of actually saying 7 minus 2, we're going to have 7x minus 2. Okay. Remember that ultimately we're obtaining a new function. So we should not end up with just a single entity as our answer. Okay. The last step for this problem is going to be a division by 3, because that's what's next to the y. So we divide everything by 3, and we're left with y is equal to all of this. Now at this point, if we can simplify, let's say this was a 6, we could have said 6 over 3 is 2. We could have done that as well. But luckily for us, these are all prime to each other, 7, 2, and 3. They don't divide into each other at all, so we can just leave it like that. So 7x minus 2 over 3. Okay. On some of the quizzes and tests that we might have, this might just be your answer, the final answer, but we want it exactly correct. Okay, we change this term right here into our inverse. So f of inverse of x is equal to all of this, 7x minus 2 over 3. And this is our answer. Okay, go ahead and do another example. Let's say we have something a little bit more complicated, say like a quadratic. Okay, so y equals, we'll say 7x squared minus 14. Okay, so just like before, I'm going to go ahead and switch my x and y first. I'm going to go ahead and do it right next to it, and then we'll go down from there. So we'll have x is equal to 7y squared minus 14. So there's that first step, switch x and y. Then I need to isolate my variables. Okay, in this case, I'm solving for y. So that means I need to get y by itself. So the first thing I do is I get rid of that 14 by adding 14 to both sides, which gives me 0 here. These are not like terms, so I'm going to go ahead and say x plus 14 is equal to all this, 7y squared. Okay. And then my next step would be to divide, because that is the 7 is next to y squared. We can't get rid of the square yet because that's the closest thing to the y. So divide both sides by 7, which turns this into a 1. Oh, sorry, turns that into a 1, so it's gone. Okay, I'm going to make a note here. Here we could technically simplify this right here. So for the sake of just seeing it once, let's go ahead and do that. This is the same as x over 7 plus 14 over 7, and I'm just rewriting this right here. So this is all equal to y squared. We got rid of the 7 there. And if you look at this, this part right here will simplify. So if I rewrite that, I'm left with x over 7 plus 14 over 7 is 2. Okay. And again, I still have that y squared. I'm just going step by step here for those of you who need that extra support. Okay. My final step in this equation, I know this is a lengthier one, is to get rid of this little 2 here, this square. So at this point, you do need to know that the inverse of x squared is going to be the square root. So we need to square root both sides. So square root, square root. Now, whenever we take the square root of something, we need to consider both the positive and the negative aspects of it. So that means I have to have that little plus or minus. Okay. Go ahead and pay attention to me in class for this, because there are times when this is not applicable, and I will let you know when that happens. Okay. So anyway, we're going to be left with y equals all this. So the square root of x over 7 plus 2. And again, this part will just cancel itself out. So we're left with that y. Final step, rewrite this, because we don't want to leave it as a y. We want to write it correctly. So f negative 1 of x is equal to plus or minus x over 7 plus 2. And let's just say you hadn't simplified that 2, you just left it as a 14. That would have been correct as well. So this could have also been x plus, what was it, 14 over 7. And that would have been correct as well. Okay, but this is a little more simplified. Let's see if we have time for one more. Give me just a sec. Okay, it looks like our time's almost up, so we'll go ahead and stop there. If you have more questions, please let me know, and I'll gladly help you in class or put up some more practice if you need it, okay?